Okay, so now today we are to solve the challenge problem of the chapter 6 is the right triangle. It's basically for the right triangle, the most important thing is the Pythagorean theorem. So let's see the first problem. So we want to find the Pythagorean triples. Okay, means the three sides are all the integers. So in which 18 is one leg, right? So if 18 is one leg, we have a right triangle, right? So you can see C and B, for example, this is 18, so we have the C square is equal to the 18 square plus the B square, so we have the C square minus B square if 18 square. Okay, that's A. Then B, we can factorize the C square minus B square is this equal to the 18 square, right? Since we know the C minus B is less than the C plus B, then we can do a table. Right? Normally I like to do in this way. Now we can solve the C and we can solve the B. Okay. Okay, so let's starting with the 1, right? It's 1, 324, and the 2 is 162. Then we have 3, 8, we have 4 is 81, we have 6, 5 doesn't work, right? 54, 7, 8, no, 9, yes, 9 is 36, yeah, 11, 12. Then we have 18 is 18, right? So it doesn't work, right? So 18 cannot work, okay? Because C plus B need to be greater than C minus B, okay? So now we can see that this C minus B plus C plus B divided by 2 is C, right? So this not integer, not integer, not integer, not integer, not integer. So the only answer is 2 and 162 give us answer of the 82 and 80. And this one gave us the answer is the 30 and the 24. Okay, so this is the Pythagorean triple. We already solved it. So if you want to write them down, the first is the 18, 80, and 82. And the second one is 18, 24, and 30. Okay, next. Okay, so find the Pythagorean triple that has 97 as the length of the hypotenuse, okay? So we have the x squared plus the y squared, these are two legs, right? Is equal to the 97 square. Okay, we want to find the x and y. So if you remember the Pythagorean triple is have a format of this. So that means because 97 square, right? That's pretty big. Now we need to, let's evaluate this. Okay. Now let's do it without loss of generality. We can see m less or equal than n. Otherwise, you can flip it. Okay. M and then let's do it So m is 1, 1 square, m square, n square, right? 1. 1 square, 96. 2 square, 93. 3 square is 88. The 4 square is 81. This is 1. 5 square is then 6 square is 7 square is minus 50, 47, 48. Okay, so m less than n, right? So this is done. So now we find the Pythagorean triple is a equal 81 minus 16, and c equal 81 plus 16, and b is 2 times 4 times 9. So first is 5, 6, 5. This is 72, and this is 97. Okay, so the Pythagorean triples are 65, 72, and 97. Next, so a right triangle has area of the 210 and the hypotenuse of the 29. Find the perimeter. Okay, so we have a right triangle of the ABC, and this right angle, we have this 29, and the area. So now we know the height, right? That's planar height. So this is the h. So we know half of the 29 times h is 210. So we know h is equal to 420 divided by 29, right? This is the first part. So in order to solve the perimeter, we need to the ABC, right? So you can see the h. Okay, okay. Let me talk about something very important for the similarity triangle of a right triangle. Okay, the similarities. So let's see. This is A, B, and C. Okay, and we can land on the h. Let's see. We have this one is P, and this one is the C minus P. Okay, by similar triangle, right? So we have this one is theta, this one is theta, right? Because theta plus this one is 90 minus theta, this one is 90 minus theta, right? And this one is D. So by similar triangle, right, we have by triangle the ACD similar to triangle the AC, okay, is similar to triangle the ABC. Then what you can have is the B square equal to the P times the C. Okay, so the square of this one square. Okay, let me highlight the B square. Okay, is equal to the P square, P times the hypotenuse. Okay, and the other one you can get is the A square is equal to BD. Okay, this is the one. The second one is the A square is equal to the C minus P times C. Okay, and the third one you can get is H square. Okay, that's this one is equal to P times C minus P. Okay, all these are from the similar triangles. So this one from the similar triangle, the BCD is similar to triangle the BAC and this one from the triangle ACD, similar to the triangle BCD. Okay, so these are very useful information. Okay, we need to remember for the right triangle. Okay, very useful. This is a side. Okay, so this one is very useful, right? So we get the H. So we want to get the A and B, right? So let's, if we set this one to X and something where it's not easy, let's see, okay? So we have this is X, right? This is the 29 minus X. Oh, let me set this one to Y. It doesn't matter. Let me set this one to Y, right? So we have the X plus Y is equal to 29. Okay, and we have the X times Y is H squared, right? Okay, so we also have the B squared is X times the 29, right? And the C squared is Y times 29. So we know the B is equal to the root 29 root X, and the C is the root 29 and the root Y, right? So the perimeter is equal to, A is A plus B plus 29 is equal to okay. Now we try to solve this one, right? Let's see this. Okay, so this one we already have here, 29 plus 2 root of this, right? So right, so now we can see the root X plus root Y is equal to root of the 29 squared plus 2 times 420 is equal to root 29 1681 is 41 is root 29. Okay, now we can apply this one back to here. Okay, then equal to root 29 times the 41 is root 29 plus the 29 is equal to 41 plus 29 is 70. Next, okay, so this one is what's wrong with the diagram of left below. Okay, so now let's see. So we have a this is the common side, right? Okay, this side equals this side. Okay, so that means right triangle POQ congruent to right triangle ROQ. Okay, that means RO equals PO equals 4. Okay, so now we have two ways to solve the OS. OS is OR plus the RS, right? And you can solve the RS through triangle QRS. Okay, so RS equal to 12 minus 3 square is equal to 144 minus 9 is equal to 135. Right? So the RS is 3 root 15. Now the first method, right? This is the first approach, means the first way. Okay, so we have the OS equal to 3 root 15 plus the 4. Okay, now let's use it the second way. We have the right triangle POS, right? So now you know the OS is also equal to the 4 square plus the 15 square is 1, 4. Right? So the question is, now we have two ways. Now Q question is, does the OS equal the OS? Okay, you can see, you can go check it. Of course it's not. Okay, that's why this diagram is wrong. Okay, next. So we have a rectangle A, B, C, D. Then we have a diagonal, and the P is on this to trisect. Okay, so we have a P. Okay, since we trisected this angle, right? So we know it is 30, 30, and 30. Okay. So what is the perimeter of the AD is equal to 1? What is the perimeter of the BPD, right? So you can see triangle APD is 30, 60, 90, right? So you know if the size is A and it's root 3A and 2A, right? So we know this one is 1, right? So it's 1 over root 3, right? So this is 1 in this case. Then this is 1 over root 3. And the other one is 2 over root 3, right? Okay. Now we have another triangle of the BDC is also 30, 60, 90. Okay. So this is the 1, this is 2, right? So you know this is root 3. Then you know the PB is equal to the AB minus AP. Then equal AB equals CD minus AP is root 3 minus 1 root 3, right? So it's the Okay. So now you can see the perimeter of triangle BPD is equal to 2 root 3 plus the 2 root 3 plus 2 is 2 plus the 4 3 root 3. Okay, next. So the hypotenuse of the triangle, okay, let's see. We have a right triangle of the ABC. Hypotenuse of the right triangle has a length of 8. The triangle has also an area is also 8. Okay, so we know the area is also 8. Find the perimeter. Okay, let's do it. So we know this is 8, right? So half of the 8 times the h is 8. So we know the h equals to 2. Right? So let's assume this the perimeter. Let's assume this is the A. This is the A. This is the B. Right? So we know the let's see. This is the x and 8 minus x. Okay, so now we can try to solve the a and b, right? We try to solve the a plus b, right? So now let's see, we can have the similar triangle. We can see the a times b. Half of the a times b is also the square, the area of the triangle is equal to 8. So the a times b is equal to the 16, right? Then the a squared plus b squared is also to the 8 squared. Pythagorean is 64. Then the a plus b squared is a squared plus b squared plus 2ab is equal to 64 plus the 32 is 96. So we know the a plus b is 4 square root of 6. Now the perimeter is a plus b plus 8 is 8 plus 4. Okay, this is the first way. The second way is the same thing. Okay, basically we can also use the similar triangles. Here we have the 2 square, right? Well, I teach you before, this square is equal to the x times 8 minus x. So we can also solve, this is the method 1. For the method 2, right, we can solve this equation, x squared minus 8x plus 4 is equal to 0, right? So we can solve this one. So it's equal to 64 minus 16 is 8 is 48. So see, you still need to know how to solve the you still need the basic algebra, right? How to solve the quadratic equations. Then it is 8 plus minus, it doesn't matter because you can see plus is this, the minus is this. Okay, let's take one of them. it's okay. Then you can use the Pythagorean to solve the a and b, right? Since you know it's 2, you know this one, you can solve the a and b, and you can also solve the perimeter. Okay. The rest of them I leave for you. Next. Okay, so we have a common side of the AC, and we have two right triangle is D and B. Okay, so if you see in the future, I mean, of the concyclic, right? This is a very important structures. So you can see the AC, right, spans two angles. This is 90 degrees. This is 90 degrees. So they must be on a circle. They must be on a circle with so the A, B, C, D are concyclic, okay, with AC as diameter. Okay, so that's why you have these two right angle. And also we have the AB equals CD if 24 and 24, right? So if you see this kind of 24, 24, and in the future in the circle, okay, I want to teach you is if you see the two chord is the same, okay, this means the arc span of the chord is also the same. Okay, if we have the two chord is the same, means this arc equal to this arc. Okay, then if you can connect it to this 4 point, okay, so you have a quadrilateral. Okay, this quadrilateral must be an isotrapezoid or especially a rectangle. Okay, so yeah, I mean, if you're very familiar with this, and we can see it directly. Now you can see is we have the sides are equal, right? And we have this angle equal this angle so that's why AAS. That's why according to AAS, okay, the triangle ABE is congruent to triangle CDE. That's A and B. So if M is here, right, it wants to prove the EM perpendicular to AC, right? Okay, so from here we know the AE equals CE, right? If AE equals CE, then M is the median, right? So EM is median on base AC, right? So that means also EM also a bisector of you'd better see this first. You'd better see triangle AEC is isotriangle. Okay, see this one first, then see this one second. Then we can also have 2 prime and the 2 prime prime bisector of angle AEC and the EM perpendicular to AC. Okay, so these are all the properties of the isosceles triangle. The last step is the C. Find the area of the ACE. Okay, BC equals AD is 32. Okay, so let's see. So in the right triangle ABC, right? So AC square is equal to 24 square plus 32 square. What's that? Is equal to okay. Now we can have the 20 and the 20, right? So you can see we have another similar triangle. Help us to solve EM, right? So this triangle EMC, similar to triangle EM to AB, ABC, right? So let's assume EM is X. So X over 20, 2 legs, right? X over 20 is equal to the short leg 24 divided by the long leg 32. So X is equal to, this is the 8, 3 and 4. So 3 over 4 times 20. So it's 15. So now we have X equals to 15, right? So now you can see the AEC, half of the 40 times the 15 is equal to 300. Next. So triangle ABC has AB equals to 12 and BC equals to 16, AC equals, okay. So AB, let's take out some common factors, okay, to make it clear. 3 times 4, BC is 4 times 4, and AC is 5 times 4. Okay, so you can see a common is this is the scale. So basic triangle is 3, 4, 5. So here is the basic 3, 4, 5 right triangle. So A and C and B is 12, 16, 20. D is on AC such as AD is 12. 12 and 8. Find the area of the ADB. Okay. So you can see we have a common height, right? So triangle ABD, right? Against the triangle of the ABC. Yeah, we have same height of H, right? And so it's equal to the sides EAD over the AC is 12 over 20 is 3 over 5. So that's why the ABD is 3, 5 of the triangle ABC. The triangle ABC is easy to calculate, right? is half of the 12 times 16 is, right? So you apply this back. Next. So riders of a Ferris wheel in the circle of the vertical plane. A particular wheel has a radius 20 feet and revolve at a constant rate of 1 revolution. Okay, 1 cycle takes 1 minute. Okay. So this is the Ferris wheel. This is the center O, and this is the 20. From the bottom wheel to the part of the 10. Okay, so 10 is the midpoint of here, right? This is the 10 and the 10. So, and this one is 20, right? So you can see from this point to this point back is 1 minute, right? So it's 360 degrees. For point A, rotating 360 degrees takes 1 minute or 6 seconds. Right? So the question is asking you to this point. So we want to know this angle, right? So this is the Pythagorean, right? So you can see it's 10 and 2 is 1 over 2, right? So this basically is 30, 60, 90 triangles, right? So you know this angle is 60. So this arc is 1/6, right? So 60 over 360 degrees is 1/6 of cycle. Right? 1 cycle is 60 seconds, so it takes 10 seconds. Yeah, and I will recording the rest of problem on the second half. Thank you.